Good evening, class. It's Monday, May 22nd, and this is the lecture for Leadership Studies, Data-Driven Leadership 321, Week 1. All right, I'm going to share my screen with you and get on with the show here. If there are any questions as you watch this video, please jot them down and send me an email with the question. I will respond back probably in the announcement tab or the discussion tab, unless it's just a personal question, in which case I'll just respond to you via email. Okay, so if we go into the class, this is actually what I see. Here's the home page. Very much like the last class. You can find my phone number up here, email, Q&A, which goes to the discussion forum, and then of course check the announcement tab on a regular basis to see if there are any new announcements. If you haven't already, go here and read my welcome message. Click here for the syllabus. Here are the books we'll be using. And this statistics book is just it's a free optional textbook. We're not going to be using it, but if you hear some terminology in this course and you're not sure what it means, you could Google it, or you could go to this textbook and see if you can find the answer there. Once again, I'll be making use of the modules, so this is kind of a nice view to go to if you want to see what the course entails here. And week 1 slides. Now I want to make sure that the slides were updated here. The slides should be uploaded, the new slides here. Let me just double check. Okay, yeah, this is the recently updated slide deck. Okay, so here we go. Do you see the slides?
Yes.
Okay. All right, so what you should do this week is review the syllabus, which is available from the homepage. Take a look at the overview of the course and the course map, and I'll have those in the slide deck so you can take a look at that.
Okay.
Review what the assignments are, and then get into this week's assignments. And then attend this lecture or watch it on a recording.
Okay.
Which this will be available on the announcement tab tomorrow. So
okay.
the recording. Write down any questions you have as you're reviewing the syllabus. Here's an overview of this course. Basically, the first week is an introduction. Then we're going to get into some data analysis and some math, but I think it's taught in a way, the book teaches it in a way where it's easy to understand, even if you haven't had a statistics course.
Mm-hmm.
And then we'll switch gears, and then we'll get into basically, for the last half of the course, an analysis, and you'll basically do an analysis, and then you'll write a report of that analysis, and that's basically the capstone project for this course.
Okay.
You have to do the analysis to write the report, so it's not just a written report. It's actually, going out and finding the data you need for the decisions that you want to make.
Okay.
And then the last week, you'll write a memo on how to address how to make data-driven leadership decisions with regards to your leadership plan. So, and that'll be in the form of a memo. You'll write a memo to either me or to your to somebody at your work. It could be your supervisor or it could be your subordinates, depending on where you are in the organization.
Mm-hmm.
And we'll learn more about that as we get towards the end of the class. That's once again week 8, the last week.
Okay.
Here's a course map. This gives you an idea of how many points you're going to see in the different sections. So the first week, basically 6.25% of the course grade is going to happen. And that's going to be in the form of this Sharpen Your Pencil assignment.
Mm-hmm.
Titled Sharpen Your Pencil because that's what the textbook calls these activities. So it's basically following along in the textbook and then in your own words, answering the questions for those activities, submitting those to me in a Word form or a Word document form. There are templates for those assignments, so you'll find those on the corresponding week where those assignments are.
Okay.
And then weeks 1 to 4, really 2 to 4, but you can begin in week 1 as well, is going to be 3 of those Sharpen Your Pencil assignments.
Mm-hmm.
And 3 quizzes. So it gives you basically 33.75% of your grade. So if you just add up the introduction, week 1, and then weeks 1 to 4 with the data analysis, workplace decisions, you're looking at about 40% of your grade right there.
Okay.
And then you get into the final 4 weeks of the course, and you have 60% of the course right there.
Mm-hmm.
And that's a bulk of that is going to be basically that analysis report. That analysis report is worth 30% of your grade.
Mm-hmm.
But once again, it's not just a report, it's an analysis. That's why it's worth so much. It's going to take a long time to develop that.
Okay.
In addition to that, you have some quizzes, and there's a video assignment that's related to your analysis, where you basically just post a video talking about what you plan to do early on. And it's really a way to get feedback from your peers and from the instructor via the discussion page.
Okay.
And that's the course. This gives you an idea of the readings involved and also these student learning objectives involved with those assignments in those weeks. Here's another way to look at it. These are, there's 100 points possible. 25% is going to be from quizzes. 25% is going to be from the activities. And 10% from the video, 30% from the analysis and the report, and then 10% from that memo in the final week of the course.
Okay. So for clarity, we're doing every single Sharpen Your Pencil exercise within the chapters that we're reading, right?
Correct. You're not going to read every chapter, but the ones that I have assigned, you'll be doing all the activities in there.
Okay. Okay.
And there's some, I'll say this now because it's come up. There are some versions of that textbook where they have the answers basically in the textbook.
Mm-hmm.
Do not copy verbatim what's in the textbook, because
Okay.
I will call you on it. I've had to talk to students in the past about plagiarism. Really, it's the honor system here. Try to figure out the answers yourself, and really try to work through that and kind of learn the lesson that they're trying to teach you.
Okay.
So this week, you have the data analysis assignments. If you don't have the book yet, there is a free version online that you can find, or you might be able to find. It's a PDF version. It might be linkable to from the course website where I actually had a link listed with the book. I know it takes you to a site where it gives you a lot of different options to buy the book.
Mm-hmm.
It's a good book to have on your shelf, so I'd recommend buying it. I don't think it's very expensive.
Yeah, I don't think it was either. I have it. Yeah, so it's really easy to understand. So yeah.
Yeah, awesome. Now, one last thing on that textbook. There was only one edition published of that, and there were, just like they are with every book, errors.
Mm-hmm.
Most of them are minor errors, but there are some that some people scratch their head because it's basically a computation error where they're not coming up with the same answer, and it's because the book made a mistake.
Mm-hmm.
Now, I have on the announcement page a link to a list of all those corrections for that.
Okay.
So check that out. If you're scratching your head, if something doesn't seem right with the book, go to that page and see if there's an error.
Okay.
All those assignments are due at the end of the week, which is Sunday at 11:59 p.m. And really, with this class, you want to stay on top of those assignments. You don't want to fall behind and wait in this class.
Okay.
Just like any math class, it's not a hardcore math class, but just like any math class, you don't want to fall behind. You want to keep going and kind of do it daily, weekly.
Mm-hmm.
All right, so that's the end of the kind of the housekeeping portion of the course. I'm going to get into kind of a lecture for week 1. Some of this will be on the quiz, so you can go back and take a look later if I'm going too fast, or when you're doing the quiz. So what is data-driven leadership? It really is making good decisions using data in the workplace. It doesn't have to be the workplace. You can make data-driven leaderships in your personal lives as well. And I would like to apply it very broadly. In doing so, you have to understand the difference between quantitative and qualitative data. You also have to understand the terms of validity and reliability in a general context. And the same with correlation and causality. There's a difference between those two, and it's good to understand those two and how they relate to data. There's some other useful terminology that we'll cover, and then we'll look at some data-driven leadership models that exist. And then finally, kind of a precaution, 3 things to know about using data in the workplace. So quantitative, qualitative data. Basically, quantitative is numbers. So if you think about collecting lots of survey results and then looking at them in terms of numbers, for example, 75% of the population preferred Coke over Pepsi or something like that. That's quantitative data. It can be in percentage. It can be in numbers. It's usually a type of data that you can generalize from as long as you have a representative sample. And a representative sample is just that. It represents the population that you're trying to generalize to. Now, qualitative data is not generalizable for the most part. You can think of it as anecdotal in a sense, but it is an important, if you do it right, qualitative data is very important way to collect information about what you're studying. You're going to see a lot of qualitative data in fields like sociology and anthropology. And education as well. And the reason we do qualitative data is to answer the question of how or why. So if we get this data where it says, say, 70% of a certain population are not college ready once they graduate from high school. Well, you want to know, well, why? Why is that the case? So to answer those questions, you can't just look at numbers. You have to go in, you have to find out what's going on there. And that's where you would have case studies. In some cases, you might have people actually, the researchers actually going in and living with the population. When we hear about like Jane Goodall, who went down and lived with the chimpanzees, that was qualitative. That was a form of qualitative data. She might have been collecting quantitative data as well, but by living and living among them, she's really collecting qualitative data. It's basically those individuals that she interacted with. So that's why she can't really generalize from that. Typically with qualitative data, you're going to form your theories from what you find. Whereas in quantitative data, a lot of times you have your theory in mind when you go in to collect the data. So that might be a concept that's a little bit unrelated to this course, and it might not make sense right now, but if you go further in your education and you decide to do some data collection, some research, I think it'll come in handy to know that. For this course, for the most part, we're going to be looking at quantitative data. So the terms of validity and reliability can be understood by looking at this bullseye chart. What we're really looking for is valid and reliable data. And if we look at the bullseye from number 3, that's a representation of a valid and reliable, say an archer in this case. So the person is hitting the target and they're hitting in the same place of the target where they want to hit, right? If we look at number 2, we see a cluster of those shots right there in the bottom left-hand corner. So in that case, you have you're very reliable in your shot, but your validity is off. You're not really hitting the bullseye. So another way to think about this too is if you're collecting data, or if you're making decisions from data, you want to make sure you're making the right decisions, and that you're looking at the problem at the root cause or the strategic need, and you're not just collecting data without really analyzing really what the problem is. And so you want to figure out where that target is. You want to figure out where the bullseye is. The other ones, number 1 is not reliable or valid, really. And then number 4, you have a moderate degree of validity and reliability. Not as clustered as number 3, but pretty decent. The idea of correlation and causality is something that always gets, I think, messed up by people, whether it's media or lay people, or maybe even some novice researchers. So here's an example of that. This is a graph of on the x-axis we have radon. On the y-axis we have IQ. So if you look at this, it tells you that, it appears as though when radon levels go up, IQ goes down, right? It would be a negative correlation. But some people might incorrectly look at this and say, oh, radon causes IQ to go down, because they just see the data points. It looks pretty clear, right? They drew the line right through. Say that's the average of those plots there. But what they're not taking into account is the possibility of a third variable here. So if we look at this one here, the third variable in this case is lead. So it just so happens that lead emits radon, which is a gas. So where you have high levels of lead, you have high levels of radon. Radon can exist without lead. So we know there's a link between lead and IQ, and they've studied that, and that's the causality. However, there is not a causality between radon and IQ. That's a correlation, because the two are not directly linked. And so oftentimes what we want to do is be a little bit cautious of saying X causes Y, or 1 causes 2, or whatever it is. And we want to speak more in correlations, that it seems like these variables are correlated. That's a safer way to say that there's a relationship, but it's not a direct relationship, or it might not be. It might be, it might not be, but it's a little bit of a more cautious way, and more, I think, in a more educated way to talk about the data there, rather than jump to causality when we don't really know for sure. So causation, same thing as causality. It's a cause and effect correlation. Mean, medium, mode, those are all averages. The one we think about mostly is mean, which is basically how we figure out the average. Typically, what we think of as the average, which is you have 10 runners in a race, and they all have different times. You add up the times, and you divide it by 10, and there you have your average race time, right? Or your mean race time. The medium is the middle number. So out of those 10 runners, it's going to be right in the middle, right? Whoever's right in the middle of that, their race time. If you have an even number of participants, like we do with 10 runners, it's going to be right between 5 and 6, whatever the score is in between those two. If one of them is, say it's a mile run, and 5 has a 7-minute mile, and 6 has a 7.3 minute mile, then it would be a 7.2, I think, or 7.1.5 rather, minute mile, or 7.115. Mode is the most frequent number. So once again, if we have the numbers and there's 10 runners, and say there happens to be 3 people that pass the finish line. I know this is not the great example, because you can always kind of separate people when they're running a race by fractions of seconds. But if we had everybody with the exact same number, say we had 3 people end with a 7-minute mile, and that was the most frequent score. All the rest were different. So the mode would be 7. It's whatever number, whatever score appears most frequent in the data set. Standard deviation is basically a variance from from the mean. So you can think of a bell curve where if you think about the number of participants in, say, a race on the y-axis and their times on the x-axis, that middle, what you're likely to see is somewhat of a bell curve where everybody's kind of clustered into this mean area. And then from the average there, the standard deviation would go out from both sides. So basically, you're collecting both numbers that are below the mean and above the mean as you go out. One standard deviation, say you have 67% of the population in that middle chunk, and you go out and again for 2 standard deviations and you have, I believe it's 97% of the population. And then once again, a 3rd standard deviation, you have 99.9% of the population. And then what we call the ones on the outer ends, the fringes out there, 3 standard deviations away from the mean, is we call those outliers. They can be outliers on the low side or outliers on the high side, but they're just out there. They're not real similar to the rest of the population. Once again, that free stats book is on the course homepage. So if you want to check out more about statistical terminology, check that. So let's get into models for data-driven leadership. Really what we're talking about is a systematic process to make decisions, leadership decisions. They all have basically, there's a prompt, and it's usually in the form of a problem or an opportunity. And then a decision, really. I know it says knowledge leads to recommendation or decision. And that knowledge could just be the knowledge that exists in a leader's mind to make that decision. Or it could be knowledge gained from collecting data. So let's look at some different models. Model 1, no analysis. This is just, you jump in reacting. You're just reacting to, a need. Sometimes we need to do that. In emergency situations, we don't have time to really analyze problems. If you work in law enforcement, if you work in the Coast Guard or the military, the fire department, they operate on this model quite a bit, and that's why they train so much. So they train so much that they don't really have to think about it and analyze it at the time when they need to just take action. So just jump to action. Model 2 is a wisdom pyramid. So this is, if you think about this in terms of a traffic stoplight, the raw data is basically, it could be on a computer, it could be basically an IP address that basically tells you a computer somewhere that this street light has turned red at this address. And the meaning of that is basically that the south-facing traffic light on the corner has turned red. So it's a little more information, right? It's not just the whatever the computer recognizes as the IP address or whatever it is. Now, the context of that information is that if somebody is driving towards that red light, they better use that. They have the knowledge now to use to make a decision. So it's now the information becomes useful. And then the wisdom is, I better stop the car. I don't want to get a ticket. I don't want to get in an accident. So this is kind of going from the nuts and bolts of here's some data to what is information based on that data, And based on that data, what is knowledge? And based on that data, what is wisdom? And all kind of builds up to basically a decision, and hopefully the right decision. The textbook describes this model. They define a problem, they disassemble the problem, they evaluate it, and then they decide. And when they disassemble, they're breaking the problem into smaller pieces. And then the analysis, where they call the analysis is the evaluation of the data. I think other models might include step 2 as an analysis when you're disassembling the problem, but not the textbook. And then my view of the world, based on my Coast Guard experience and the analysis that I've conducted, are that you define the problem, and then based on that problem, you gather the data that you think will be useful. And by the way, this is probably the longest part of this particular model, because you might have to go back if you don't get what you think you need. You might have to go back and get better data. You might have to get more data. And then based on that data, you construct the knowledge. And that's where the analysis takes part. And then you make a decision based on that knowledge. And then you evaluate that decision that you made based on that knowledge. And by the way, it's cyclical, so you can go back and construct new knowledge, make different decisions, or adjust your decisions based on this process. This is the process, for the most part, that we're going to get into in the last half of this course, which is the performance analysis or the needs assessment approach. Some things to know about data, especially if you're working and you're not used to dealing with data, you don't have a lot of good data available to you. You don't have a department at your work that's focused on data analysis or data collection. You want to think about triangulation. So and we'll get. I think I have a little example of that in the next slide. But second thing is analysis paralysis. So you don't want to just jump to decisions, but at the same time, you don't want to be so mired in the analysis process that you never get to that decision point. So you have to be, sometimes you have to be willing to just say, you know what, we're going to go with this. We've collected the data that, we've made a good effort, and you go with the best decision you can make based on what you have, and so you don't get paralyzed in the data analysis process. Another reason you don't want to take too long in the analysis process is because things change. And if you're doing an analysis on something and it takes you 6 months or a year to do, when you started collecting that, and when you finished, it might be a completely different. There's a lot of things that can happen. It might be a completely different situation. So you want to be able to do this fairly quickly, weeks, maybe on a really big analysis, maybe months, but certainly not more than 6 months, I would say. And then you want to make a recommendation that will hopefully help your career and not hurt you. And we'll talk a little bit about that. Once again, I'm kind of focusing this on the workplace, but once again, you can use data-driven leadership decision-making for your personal life, for, buying a car, trying to determine maybe a career path or a school to go to, a school program. You can really use this idea of, I'm going to go collect data to make the best decision I can. You can use it with just about anything. And usually I'll use it for the big decisions. Picking a career, looking at grad school choices, looking at making a major purchase, something like that. So here's triangulation. This is what I was talking about. If you don't have real good data and you have to go out and collect data, and you know that your data is going to be somewhat limited in terms of the generalizable, or in terms of your ability to generalize from the data, then you want to make sure you collect different sources of data. So you can do interviews with leadership, and in this sense, we're once again back in the workplace. We're talking about that. So leadership would be the folks that have the vision and the mission of the organization, the strategic intent, if you will. They have that in mind, that they're thinking about it. That's what they should be doing. And then survey data, that can be from groups of people that are important to survey. And then, of course, existing data that might be around earning reports in this case. So once you have those, then you can kind of triangulate and see where you have some overlap with the data. What is the data saying in this case? And you try to find that mark. We talked about analysis paralysis. Once again, these slides are on the webpage, so you can go back and take a look. So we talked about making a recommendation. So in a lot of cases, we're not the decision maker for the data that we're collecting. If you're middle management, if you're a supervisor, if you have a boss, which most of us do, a lot of times you're going to collect the data and you're going to come up with a recommendation. You're not going to make the actual decision. And that's okay. That's a valuable thing to have. Every leader likes a person that can actually come up with a good recommendation that's based on some sort of data. In that sense, so we talked about not making a recommendation that will hurt your career, and I think that's where that be humble comes in. You never know if your if your recommendation's gonna be the right one or not. Sometimes you have a better idea and you have more confidence in your recommendation, but it's best to hedge your bets a little bit and be humble when you present that recommendation. Don't be arrogant. So really what we're looking at is making the best decisions we can using the best data, the most reliable and valid data that we could find for the decision we want to make. And we want to do that so we're more effective in the workplace. We can build efficiencies in the workplace. Yeah, that's about it. One thing that, when I was developing this course is big data was a huge thing in the business world, and also as a result in the TED Talks and videos like that. And you will just find some really interesting TED Talks. This is one of them. Kenneth Cucker. His video, Big Data. I haven't seen it in a while, but really, it's amazing what they can do with large quantities of data. Anybody that uses Amazon.com, iTunes, any of these big companies that collect data, metadata, if you will, on their customers, and then they basically turn around and basically tell you what you want. You know, they give you recommendations on purchases, and they really influence people on what they buy, and that's where a lot of large companies are right now. That's not what this course is about, but I think it's really interesting, and some of you might be working in those fields, or you might have an interest in working in those fields in the future. So I did want to expose you to it, even though that's not our focus. Our focus is on making decisions, everyday decisions in the workplace, at home, wherever. Leadership decisions, really, because if we can make these decisions well, they will translate into, I think, better opportunities and a more successful career